we'll start almost all of our classes by just taking a quick look at our calendar. This is on the back of your syllabus, so you have it, but you don't need to take it out. Today is January 29th. We're going to cover lesson number 2. It's section 1.5 in your book. You have complete access to the entire book in My Math Lab. You might have to hunt around a little bit to find it, but it's there. In this section, we're going to talk about using equations to solve problems, that is, to solve word problems. As usual, there's always homework assigned when we cover material. Typically, it would be due the very next class, but this homework is not due on Monday just because it's the beginning of the semester. We're making it due on Wednesday, all right? So you do technically have 3 homework assignments that are all due on Wednesday, but I'm hoping people chip away at them along the way. All right, so a couple of announcements before we jump into the math. So first, we'll talk a little bit about some more handouts that I've just put out for you. So first of all, everybody grab one of these yellow Math Studio bookmarks. Math Studio is a wonderful resource. It is right across the hallway here, this big room with the glass windows, glass walls. This schedule tells you when there are math faculty members on duty to help answer any of your math questions, all right? And some people find great success just building in time in the Math Studio, just like it was another class. So for example, 8 to 8:30, if you're kind of an early riser, there is somebody. Caitlin is always covering the Math Studio the half hour right before this class, and that's a wonderful chance to answer any last-minute homework questions you have. Same thing after our class. Linda is there every 10 to 10:30 right after class. So if you can build it into your schedule, super. Okay, next handout on your tables is this one right here. It says entering answers correctly in My Math Lab. So I just grabbed this from a web page. The URL is there, but I think this is worth a read as you kind of navigate your way in this brand new software for most of you. My Math Lab can be very picky and can lead to a lot of frustration, but there are just a couple of tips and tricks that if you understand them from the beginning, you can save yourself a lot of time and frustration. I encourage you to read through this over the weekend. The last handout is the big one. It says practice problems for Math 096 at the top. And so I used to hand out practice tests and practice quizzes during the semester. I decided to take all of those separate documents and compile them into one document, and that's what this thing is. This is the list of all the practice tests and quizzes for the semester, just merged together into one packet. So the way to read this, if you wanted to, so like I said, today is lesson number 2. We're covering lesson number 2, and if you want to practice problems from today's lesson, lesson number 2, right here on the first page, you see that big chart. In the first column, you see the number 2 in bold, and if you look just to the right of that, apparently problems 4 and 5 in this packet are the ones that are relevant to what we're about to cover here. Any questions? Yes? Oh. Let's make sure it says there, and then one more. Everybody else has? Any questions on how to read that grid? Super. Okay, a few more resources for you before we jump in. Let's go to Moodle. So Moodle is, we're going to have a few things up here on Moodle. I'm not going to update it very often, but there's a lot of stuff already up there. I just want to point to 2 things right now. So if you log into Moodle and click on our class, it will look exactly like this. The very bottom link down here, I don't know if you can see it, says 096 Packet 1 updated January 27. That was a couple of days ago. And if you click on that, you will open up this PDF. And this is just a PDF of the exact packet that you have, but filled in with anything that I wrote on the board on Wednesday. So I filled in some stuff in the chart. I plotted a few points and drew a straight line. There's nothing terribly interesting on this one, but I just want you to know that you don't need to worry about frantically copying everything that I write up here on the smartboard, because you will have a digital copy up there on Moodle in full color. I'm not going to update it every day. I typically do this after class on Fridays. So once a week I'll update it, but if you want it more often than that, send me a quick email and I'll create a PDF and send it to you, all right? So that's going to be there every Friday after our class. The other resource I wanted to point to here is this link to playlist of class videos. So if you click on that, it opens up a playlist in YouTube. It's not a very long playlist. Right now it's only 1 video long, but it will grow throughout the semester. So I record all of my classes, and if you click on the video from our first class, it will look like this. Good, so you can relive the magic from Wednesday's class. This is just gonna blow up on YouTube, I'm telling you. Five views at the moment. Yeah. So anyway, I'll record all of my classes, so this is a good resource for you. If you miss class, it's no substitute for being here, but it's the best we can do. And if you're here in class and you just need to see something again, you go check it out. All right. Okay, so last thing is that, again, and I announced this before class, but we'll say it officially to everybody now. You're doing all of your homework on My Math Lab on the computer. You're going to click the little boxes and type in x equals 5. But I want to see the work that justifies what you've typed in. And so, for example, I've written here on the whiteboard, if My Math Lab has a homework question asking you to solve this equation, I don't want you to do it in your head. I want to see the steps, just like we showed the steps in class the other day. And so I don't need to see a lot of work, but I just am looking to see the work that justifies your My Math Lab answers. I will walk around and check this before class, every class, and I'll check after class. And if I have some time, I'll check during class, but my priority during class is not checking homework. Okay, so we'll figure out all of these systems, but that's an announcement that I wanted to share today. Okay, so all that said, we are on page 9 in the packet. So let's take a quick look here. Okay, we are going to jump to number 1 here. Sometimes when we are asked to write an algebraic expression to describe a situation, we may not know where to begin. Many times we know how to do the problem using numbers, like specific numbers, but do not know how to create an algebraic expression. Let's see how we can use numbers to find a pattern so that we can write an algebraic expression. So a lot of folks complain that word problems in math are the hardest part of the course. And so I'm going to present you a technique that is very simple but very powerful that I encourage you to try to use when you're just not sure how to start with a word problem. One note, this is a calculator active problem, meaning it's one of the rare problems in the packet where you are allowed to use your calculator. Right? Most of the semester, most of the problems in the packet, not going to be using the calculator, but this one we can. So here's an example from your book. The price of a 7-day Alaskan cruise, normally $2,752 per person, is reduced by $1.75 per person for large groups traveling together. How large a group is needed for the price to be $2,500 per person? So that's the question. Now, some of you might already know what to do with those 3 numbers to figure out the answer to this problem. Lucky you if that's the case, but even if you can't, and I can't, we're going to come up with an algebraic way to solve it. But before we do, we're going to do something more specific. In the table below, I've chosen 2 random numbers to put in the first column. This column here is the number of people traveling in a large group. I've decided on 10 and 50, just 2 easy round numbers. We're going to fill in the first 2 rows of the table. First row has already been filled in for us, and we'll leave the last row blank for now. So let's take a look at this first row. Suppose you have 10 people traveling in your group. How much is the discount per person? $1.75. So if we want to find out how much our total discount is, we're going to take the 10 people and we're going to say, hey, each of them is worth $1.75. What would we do with those 2 numbers to find the discount? Multiply. Does that just feel natural to most of us? Right? Every person is worth $1.75 off. We've got 10 of them. So how about we multiply 10 times $1.75 and get $17.50. $17.50 is the discount. We're going to take that away from what number? From the $2,752, from the normal price. We're discounted by $17.50, and we get $2,734.50. That is the cost per person for the cruise. The ultimate goal of this question is to figure out how many people so that the cost ends up being $2,500 per person. We're not there yet, but this was a fairly straightforward calculation that's going to give us insight into how to solve this problem algebraically. Can you guys right now fill in the second row here? We've got 50 people. Again, feel free to use your calculator, but write down a little bit of stuff before you type anything into the calculator. Okay, any questions on the process there? Same idea as before, 50 people. Multiply that 50 by the $1.75 discount per person. That gives you $87.50 off, so we subtract that $87.50 from the original price. Super, $26.64. We're skipping the last row for right now. Quick detour. A quantity is anything that can be counted or measured. A quantity is anything that can be counted or measured. Here are some quantities. Length, weight, area, number, volume, or time. All of those can either be counted or measured. A unit is a fundamental amount of some quantity. a fundamental amount, something that we all understand what it represents. For example, inches. We all know what an inch is. It's fairly arbitrary. It's about this long, but we all understand what it means, and it is something that we're going to use to describe a quantity, like 5 inches, right? So here are some unit words: inches, pounds, square meters, cars, cubic feet, and hours. If you have a quantity word and a unit word, and you're not sure which one is which, put a random number in front of each word. The word that makes sense with the number in front of it is a unit. For example, of the words time and hours, which are both related to each other, right? They're not the same thing, but they are related. One of them is a quantity word, the other is a unit word. We're going to put a number in front of each one. Whichever one makes sense with the number in front is the unit word. 5 time or 5 hours, which one makes sense? 5 hours, right? 5 time doesn't have any meaning. So which one is the unit? Is hours, and therefore by elimination, time is a quantity word. It's something that you can measure, right? You can measure time in hours. You can measure time in other things as well. Right? There are many unit words for time, like you can measure time in seconds or days. Okay, so why do we care about quantity words and unit words? Well, it's really important in word problems that if you're going to introduce a variable like let x represent something, you've got to make sure that your definition for x includes both a quantity word and a unit word. So whenever we define a variable, we're going to include a quantity word and a unit word. So here we go. X is going to be the number of people going on the trip. Number of people going on the trip. Number is the quantity word. We are counting. Yes? People is the unit word, right? 5 people makes sense. 5 number doesn't make sense. So we've got a quantity word and a unit word, and we got to make sure our definitions always include both. So let's go back to that last row, the blank one on the previous page. We decided we were putting an X right there for the number of people. It's the exact same calculation we did up above. Here we did 50 times 175. What are we doing now? X times 175. Yeah, that's just like the 50 times 175. Number of people times $1.75. In the previous row, we had a calculation. We got 8750. I can't do anything more with 175x. It's just going to live as it is. But the 8750 always got subtracted from the 2752, right? So this next thing is going to be 2752 minus the x times the $1.75. And so I'll just rewrite that in the last column. I'll switch the order a tiny bit. More traditional to write a $1.75x, but it's okay to not write it in that order. So 2752 minus 1.75x represents the cost per person. And ultimately in this problem, what are we hoping the cost per person will be? 2,500. That was given in the problem. Make it so that it's 2,500. So are we going to put 2,500 for x? No, we're going to take this and make it equal 2,500. Force the whole thing to be 2,500. And so that is on the next page right here. $27.52 minus $1.75x equals 2,500. That's the equation. It's not super important to me that we solve the equation. It's pretty straightforward. We could have solved it last class. Setting up that equation, including defining the variable, that's the key for today. And the heart of this is that getting to 2752 minus $1.75x is really challenging for a lot of people. It is anything with x's in it where you're defining it is quite abstract. But in the table, it was really easy when I said, hey, it's 10 people, figure it out. Hey, it's 50 people, figure it out. And that's the idea, is that I'm not going to give you the, hey, it's 50 people, figure it out on the test, but you can just do that on your own. And figuring it out for 50 people, just a specific number, will often make it very easy to go to the abstraction that is x. Right? That's the heart for today. So number 5, solving real-world problems involves creating equations that represent the problem accurately. In order to solve realistic problems, we must learn how to read the information given and translate this information into algebra equation or equations. This takes lots of practice. the main thing to take away from what we did today is that if you don't know where to start, try picking some specific numbers to see if that gives you any insight. That's the takeaway. Right? Just pick some numbers. Okay, activity starts on the next page. You are first going to reintroduce yourself to the people at your table. Want to move to another table? And then see how far you can get.